For your homework, you were supposed to draw the Bohr-Rutherford model for each of the 21st elements of the periodic table of elements. The first slide on this video shows you exactly the handout that you got. I'm going to do this handout with you in a moment, but I want to move to the second slide of this video for just a second. Now, the thing I like about this image is that it shows you where on the periodic table these actual elements come from. The first tall column, starting with hydrogen, lithium, sodium, and potassium, and the second column, starting with beryllium, magnesium, and calcium, are separated by a slight little space from boron, carbon, nitrogen, oxygen, fluorine, neon, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. You'll notice that in clumping them all together like that, okay, we forget that actual middle space down here about the actual heavy metals. This is what we skipped. It's like all of this stuff down here still exists, but it's not in our actual little periodic table, and we're not going to be talking too much about it. Okay, so let's go back to the first page. I noticed today in looking over your handouts very quickly that some of you still were not drawing a proper Bohr-Rutherford element or atom. So I'm going to just go over what my expectations are for that. We'll do lithium together. Now, lithium is the third element of the periodic table. It's found in group number 1, period number 2. If lithium has an atomic number of 3, that implies that it has 3 protons. And we know that every atom in nature is essentially neutral. And if an atom is going to be neutral, that means it cannot have a charge. So if protons have a positive charge, and there's nothing else to the atom, then lithium is positive. We know that this is not the case. So something has to be there to counteract those positives. How do you get a neutral number or no number when you have a positive amount? You have to add the same amount but in the negative side. So in this case, we need to have 3 electrons, because electrons have a negative charge. 3 plus minus 3 gives us that 0 or neutral charge. Now, when we go and we draw an actual Bohr-Rutherford model, certain things have to be there. When Bohr-Rutherford discovered their model, or developed their model, I should say, nobody knew anything about neutrons. So in that actual atom, in the nucleus of the atom, the center of the atom, for all we knew, it just had this positive substance, these protons, these positive particles. So when we actually draw a Bohr-Rutherford model of any element, we don't draw the little balls in the middle here to make up the protons and neutrons, and then the first shell, and then the second shell. Okay, we don't do that. What we actually do, instead of drawing any little individual particles in the nucleus, we have our nucleus, okay, which is a nice little circle. We simply write out the positive charge. It's a characteristic property of that atom. No other atom is going to have the same number of protons. So in this case, we've got a 3 plus. Okay, a lot of you didn't do that in your sheets. So we have our 3 plus. Now we have to account for our actual electrons. Electrons are tiny in comparison, and they're on the outskirts of the actual atom, constantly moving around. However, they move around in set orbits or shells. And the rule of thumb is the first shell, the closest here, I'm just going to mark this as number 1, has a maximum of 2 electrons. So if I remember that I've got to place 3 electrons, and I place one of them here and one of them here, my first shell is maxed out. I cannot put any more electrons there. So that last electron, lithium, third electron, has to go out onto the second electron shell. Okay, so this is a proper rendition of a Bohr-Rutherford model. In this case, it is lithium. So if we do this, let's go back to our handout and let's draw these out. All right? For what I'm going to do first is I'm just going to write out what their charges are. I'm going to write out the positives, and then I'm going to draw out the actual elements. All right, the electrons on each of the elements. So here we go. Now that I've drawn all these out, and they're a little hard to see because I'm drawing with my finger, I'm going to pause it again in terms of the recording, and I'm going to start drawing in the actual electrons. But before I do that, okay, this sheet also asks you to number the groups and number the periods. Now, a lot of you had a hard time with that. Remember, the groups are the actual columns of the periodic table. Okay? So here, and I'm going to write them in their Roman numerals, because those Roman numerals are going to be very important. Okay, I will write not only the Arabic number for the group, but I will also write its Roman numeral. So this first column is nice and easy. It is group number 1, and it is also Roman numeral 1A. Here we have number 2, also number 2A. Then we're going to skip all of those heavy metals. Remember, the heavy metals are down here, and we're skipping them. We jump all the way over, okay, to group 13. But this one is going to have Roman numeral 3. A. Then 14, group 4A, 15, group 5, oops, sorry, that should be a Roman numeral, so 5A, 16, 6A, 17, 7A, and 18, which is also BIIIA. Now, when we're talking about the periods, we're looking at the horizontal rows. So in this case, I'm just going to add some color here just to see what I get. Let's give this a try. This is row number 1. This is row number 2. This is row number 3. And this is row number 4. Okay? So I'm actually going to undo all of this. And I'm going to write it in on the side. So we've got period 1, period 2, period 3, and period 4. And when we start to look at patterns in a little while, you're going to see what I mean, why it's important to know the difference between groups and periods. So now I'm going to go ahead and add all my electrons. And when we get back to the recording, we're going to look at the actual patterns here. It's a little bit rough. I tried to get my dots as close to the line as possible, but you can basically see that when you're actually drawing a Bohr-Rutherford element, your electrons follow one pattern. The electrons on that first shell, you can only have two. So the first shell has a maximum. Let me make that a little thinner. Okay, the first shell has a maximum of 2 electrons. So here you have your nucleus. That first shell is going to have a maximum of 2 electrons. The next shell is going to have a maximum of 8 electrons. The third shell is also going to have a maximum of 8 electrons. And the fourth shell, which we're only going to be working with 2 real elements in that fourth shell, okay, has a maximum of 18 electrons. All right, so 2, 8, 8, 18. As soon as one shell reaches that max number, then any excess electrons fill the next shell. And if that next shell gets filled to its max, then it goes to the next energy level or the next orbit. Okay? So that was what I wanted for your Bohr-Rutherford. All right? That's what I wanted for this actual assignment. Now, in terms of patterns, I asked you to come up with 5 different patterns. Okay? So let's have a look at some of this stuff. Now, I'm going